Today we're going to work towards building a pivot table, which is a table that's going to summarize the data from our experiment. If you built the experiment in the first part of this series, you'll already know that we have subjects studying 6 words, some are blue and some are green, and then they're being tested with those same 6 words mixed in with 6 new words. And so there's 12 words at a test phase, and subjects have to say yes to every word that they recognize from the study phase. And so the question we're going to try and answer today is, what is the probability, on average, for someone to say yes to a blue item? What is the probability, on average, for someone to say yes to a green item? And what is the probability, on average, for someone to make a mistake and say yes to a new item? And so we're going to be trying to produce a summary table like you can see right here. And so without further ado, let's get to it. All right, welcome back to the second tutorial in our PsychoPy series. Today we're going to be looking at data output from our simple experiment here, and we're going to deal with our first pivot table in Excel. We're going to look over the data file. I'll show you what's in the data file, how do you deal with it. We'll make a simple figure in Excel, and I'm going to show you how to merge files together from multiple participants. And this is the experiment that we built in the first video, so if you haven't watched that video, you may want to go check it out to see how we got to this point. Okay, so this file was saved as demo1, and here's the folder that we were working in last time. We have our stimulus file here. Here's our experimental file. This is a backup file that PsychoPy makes that you don't really have to worry too much about. Now there's this folder here called data, which I didn't create. It was created when we ran the PsychoPy experiment. And if we open up data, what we're going to find are a series of data files. And you'll see that they are dated, and these numbers here are times. So you can tell what time I made my last video if you were curious. Now these data files are what we're going to end up working with. And every time a PsychoPy experiment runs, it creates a new data file. Now these files are split up into logs and CSVs. So every time I ran the experiment, I created both a log file and a CSV. If you open up a log file, you'll see a bunch of information that you actually really don't care about. This information is there in case, something happens, you need to debug your program, and someone more sophisticated than you can take a look at it. For our purposes, the real data is in the CSV files. This is what you actually care about. So here's a CSV file from one of the runs that we ran. And we'll be going through the details of everything in here for right now, but I don't want to work with these CSV files that we created last time. I want to actually create 3 new ones by running the experiment 3 times so that we know what are actually in the files. So I'm actually going to highlight all of this, and I'm just going to delete it because we don't need any of that stuff. All that data was when we were debugging the experiment. We can just get rid of it. So let's run our experiment again. And this time we're actually going to assign a participant number. So before we weren't using participant numbers, we were just leaving this blank, and actually I've already erased the data files, but if you're paying attention or if you rewind the video, you'll see that they were all pretty much labeled the same. The only way you could tell them apart was with the date and time. We're actually going to start using participant numbers, and what you will see is that the participant number will show up in the data file name. So it'll be nice and easy for us to see which data file corresponds to which subject. So we'll go ahead and run with participant number 1. Oh, and lo and behold, we have encountered what I think is the loop bug, return for a second round. So let's just go ahead and remove the single quotes and see if that will now run. So once again, we're going to be using subject number 1. And actually, you'll notice, even though the experiment crashed right away, we have data files that now start with a 1, showing us that that is subject number 1. Now, of course, because the experiment crashed, if you open up the CSV file, you'll find virtually nothing indicating that the experiment didn't get very far. So we're just going to delete these files because we don't need them. And again, what I did to fix that is I went into the study loop and I took away those single quotes that we needed last time. Again, I don't know why PsychoPy does this. There seems to be no rhyme or reason to it. But if you ever encounter these bugs, this is basically what they are. Now, if you remember in our experiment, subjects studied words that appeared in either blue or green. So glass was blue, telephone was green, mountain was green, as you can see right here. Now, you may be wondering why we set the words to different colors. We can imagine maybe in this experiment that we told subjects to maybe only pay attention to the green words, or maybe read the blue words aloud, or something like that. So there's some kind of manipulation here. Let's imagine that we're only supposed to remember the blue words. So in the test here, let's try and only recognize the blue words. So wrench, we saw. Mountain was not blue. Land, we didn't see. Telephone was green. So we're saying no to all these things. Looking for another word that we can say yes to. I think glass was blue. And skipping all these. Okay, so I only got 2 of the 3 blue words. I know there must have been a third one. I must have missed it. And now we can just wait for the end screen to time out here. All right, I'm going to go ahead and run this experiment 2 more times. And I'm going to take participant number 2. And I'm going to go ahead and do this. I'm going to edit this out here so you guys don't have to watch me going through the experiment twice more. But the second time, I'm only going to try and remember the green words. And then the third time around, I'll try and remember everything. All right, so now with our data files, subjects 1, 2, and 3, we can go ahead and look at this data and try to decipher what is in this file and look at how we can actually parse it. So the way this data file is arranged is every single row represents some event in the experiment. So the first thing that people experienced in our experiment was the welcome screen. So if you look here, there is this first row where not too much seems to have happened. A lot of these cells are blank, but a spacebar key was pressed. And remember that we labeled the spacebar key object key welcome. So we can look at this data file and really readily see, oh yes, this was the welcome screen. We can see how long it took before I pressed the spacebar. That was half a second, so I didn't really wait too long on that welcome screen. And then you get information at the end here about the date, the time, and the subject. And so I was subject number 1 in this case. So what happens after the welcome screen? Well, after the welcome screen, you go into the study phase. And here is where you see 6 words. And so here you can see word item. This is the word that I saw in each trial. So if you rewind the video and watch the study phase, you'll see these 6 words appear in this exact order: telephone, glass, wrench, friend, valley, and mountain. And they will be assigned these particular colors. We can see other information like what study trial number was this. Computers start counting at 0 typically, so this was this was trial 0, then 1, then 2, then 3, then 4, then 5. We can look to see where was this item in our stimulus file. So telephone, so actually friend is the first item, and then telephone, and then mountain. And popping over to our stimulus file real quick, we can see friend, telephone, and mountain. So this is 0, 1, and 2. Item 0, item 1, and item 2. So the data files really organize everything that we experience, and then we can see there's another period in the middle where not too much is happening. The subject pressed I, and we can see that, oh yes, this was the key for the wait screen. So this is the subject waiting at the please get the researcher screen. And then we can see what happened at the test. Now, importantly at the test, we not only see what we showed subjects in the order in which they saw them, but we also see what the subjects did. So did the subject say yes or no to any particular item? And remember, in this experiment, we want subjects to say yes to items they saw before and no to items they didn't. And for subject 1, I was trying to only recognize the blue items. I only said yes twice. And let's see, that first item was blue. That second item was also blue. So I got 2 of the 3 blue items, which is not too bad. Now for each response that we can see not only what I pressed, we can also see how long it took me to press it. So if we are interested in reaction times, here they are. So that's 1.4 seconds, that's 0.8 seconds, that's slightly under 1 second, etc. Okay, so how do we deal with this information? So we don't want to have to sort through every subject manually like this and code things. Especially, this is a very simple experiment with only 6 study items and then 12 items at test. Imagine we had a list of 100 study items and 200 items at test. This would be too much to sort through manually. We need a way to summarize this. And so we're going to use a function in Excel called pivot tables. Before we can use pivot tables, however, we have to change these yes-no responses into 1s and 0s because the computer deals best in numbers. So let's say this. This is the coding scheme that we're going to use in our recognition task here. We're gonna create a new variable over here on the far right, and we're going to call this P yes, which means the probability that a subject said yes. And here's how we're going to code this. Let's say that whenever a subject says yes, we're going to call that a 1, because the probability of a yes when they said yes is 100%. And if they said no, we're going to call it a 0. So we can just go ahead and code this manually. Again, in the next video, I'm going to show you how to do this programmatically, but because there's only 12 items, we can code this ourselves. So yeses become 1s, nos become 0, and now we actually have some data that we can use to plot a figure. So this is the probability of yes. The probability of yes, by the way, if you know your recognition memory research, when an item is old, so if it is an item that was studied and a subject says yes to it, that's a hit. The subject recognized an item that they saw. If you see an item that is new, like land, and a subject says yes to it, then that is actually a false alarm. The subject is saying they saw an item that they didn't see. Turns out I have no false alarms here, so things are going to be pretty simple. Okay, let's create a new sheet here, and here's where we're going to create our pivot table. So in the insert ribbon, and this is different in different versions of Excel, and if you have a Mac you might have to fiddle around to find it, but there is always an option to insert a pivot table, and this is what we want. Now when we insert a pivot table, one of the first questions we're asked is to select our table or range. This is asking us where is the raw data that we want to summarize, and it's over here on our original sheet. So what we do is we want to select all of this data. So what I did there is I clicked on the column A and I just dragged it across, and I dragged it all the way over until P underscore yes. And if I click OK, then now I have a space where I can create my pivot table, and the pivot table has detected all the different variables I had in that original table. Now what I want to summarize in my pivot table is I want to know, for all the items that were blue, how many of them did I say yes to? For the items that were green, how many of them did I say yes to? And for the items that were neither, the new items, how many of those did I say yes to? So this is pretty easy to do. I'm going to use word color to sort my table. So I'm going to put word color along the columns. So let me go and do that, and you'll see this table begin to take shape. So once you put word color in the columns, what you see is it's now creating spaces for blue, green, and none. And remember, I want to know how many yeses did I produce for blue items, how many yeses for green items, and how many yeses for none. So in order to do that, I select on my pivot table again. Now I put word color in columns. If I want to look at the number of yeses, I just take P yes and I add it into values. And by default, the pivot table is summing things up. So this is if you add up all the yeses for blue items, the yeses for green items, the yeses for none items. I'm just going to center all this to make it a little easier to read these columns. But you can see there were 2 yeses to blue items, 0 for green, 0 for none. Now, if you click on the value sort of drop-down menu for PS, you can go into value field settings, and here's where you can change what your pivot table is actually plotting. Right now we're plotting out sums. Let's say you want to use counts. You want to know how many blue items, green items, and new items were actually in the experiment. If you switch it to count, then now it will count up. There were 3 blue items, 3 green items, and 6 new items. And we can go and verify that and say there were 1, 2, 3 blue items, 1, 2, 3 green items, and 1, 2, 3, 4, 5. There's another one in here somewhere. Usually, however, you don't want to sum, you don't want to count. What is very common to use is an average. And the reason we use averages, this is actually means, is because we can compare averages when we have unequal counts of items. So let's say that I said yes to 3 new items and yes to 2 blue items. and I didn't say yes to any green items. So let's say that my pivot table worked out like this. If I was looking at sums, then I would say, oh, I said yes to more new items than I did blue items, so I must have a really bad memory. But in fact, actually, there were only 3 blue items to begin with. 2 out of 3 blue items is pretty good. It's most of the items, given I missed a third of items, but it's 2 out of 3 items. But 3 out of 6 new items is only 50%. Indeed, what if this was 2? If it was 2 new items and 2 blue items, it might look like I recognized the same number of real items as I did fake items. But 2 out of 6 is only 33%. And so essentially, if you just look at sums or counts, it's hard to compare items when there are a different number of items in each category. So by having 3 blue items and 6 new items, rather than looking at sums or counts, we're going to look at averages, because averages are going to be more reliable for us interpreting our data. So it's very common for our purposes to use averages when you are looking at your data in these pivot tables. And so here we go. We have successfully analyzed data from a single subject. So the probability of recognizing a blue item was 66%. The probability of recognizing a green item, and remember green items were studied, is 0%, so I had no memory for the green items, and I also had no false alarms. There were no new items that I accidentally said yes to. Now what about those other subjects? Remember, we've got 2 more subjects. Well, we could open their data files the same way we did this first subject, and we could repeat everything that we did for the first subject, create a new pivot table, create a pivot table for every subject, and then manually copy them together. But that's a waste of our time, because computers are meant to do that kind of work. So instead of us going through each other data file, what if we could simply bring all the subjects together in one big file, make one big pivot table, and just deal with that? Well, that's what we're going to do next. So here's what we want to have happen. I'm going to open the second data file again. Imagine we told the computer how to select all the data from a subject and then paste it at the bottom of the next subject, and then go in and look at the third subject, copy all of their data, and then paste it at the bottom of the next subject. This is what we want. This is called a merged file, where now participant 1 starts us off, and then participant 2 appears, and then participant 3, and so on. And if we have more participants, the computer keeps going, pasting them all in. Now I could do that again because there's just 3 subjects, but we want the computer to do that for us. So here are 2 simple ways that you can merge your data together. I've created something called a batch merge. This is the simplest method, and if you have a PC, it's the one that I recommend. So it's a single file. Let's go ahead and edit this file for a moment, and you can see it contains a single command line. This is a DOS command line. It doesn't matter if you don't know what DOS is, but it basically, wherever you put this file, and if you double click it on a PC, it will run this command: copy all CSV files into a single file called merged file. So if we copy this file and we go back over to our data folder and we paste it, then if we double click this, we get a new file called merged file. And when we open this up, what we find is, lo and behold, all of our subjects' data files, one after the other, have been pasted in here exactly as we need. So that's the first way that you can merge files together. Now, if you don't have a PC, don't worry. I have a script called data merge, which is written in Python. So in order to use this, you have to have Python installed. If you have PsychoPy installed, you have Python installed. You need to get another program. I recommend Genie, Geany. It's a program that runs Python scripts and can be used for scripting and so on. You don't have to worry about virtually anything here. Basically, it's just a more complicated way of doing what we did with that single DOS command. So if you have a Mac or something, you might have to go this route. Basically, all you have to do is place all of your CSV files into the folder labeled in this case raw data. You could change this if you want, but we're not going to keep it simple. And then you click on execute, which is this button right here. So looking at our data merge script, there's a folder called raw data. There's nothing in there. Let's go ahead and get our data and put it in there. So we're going to get our 3 CSV files. We're going to copy those. Then we're going to go into our raw data folder, paste them in. Then we're going to click execute. It says it's done. These things finish almost instantly. And now if we look, we see we also have a merged data file, and we can open it up. And just like the other technique, we now have a merged file. So either way, there'll be a link on the lab website to get these script files. Whichever one you prefer, they both work. The net result, as long as you have a merged file, that's all that really matters. Okay, so now with our merged data file, let's create a pivot table for all of our subjects. So again, we need our probability of yes column. We need our P_yes. Again, there is a way to have Excel create our column for us, but I'm going to do this manually. And so once again, every time we see a yes, I'm putting a 1. Whenever we see a no, I'm putting a 0. I'm going to manually do this for my 3 subjects. Again, you don't want to be manually doing this for real. We're just doing it now for simplicity. The other reason you don't want to manually do this is you can make mistakes. If you write a computer algorithm that does it correctly, it will never make a mistake. So this is just for this one video. In future, in the next video, we'll see how to have Excel do this for us. Okay, we have our probability of yes items for all our different subjects. Now let's create our pivot table. So again, you click on Insert, you click on Pivot Table. It asks for the data range. Same as before, we want to select all the columns of our table and click OK. We're going to use word item again as the columns. Oh, sorry, not word item. You can see what happens if you put the wrong item in. So word item would separate out all the different words that we saw, but we want to sort things by the category that they were in, so something like word color. And then we want to have probability of yes be our sum. And now what you can see with this new merged table is that it's taking into account data from all the subjects. So we can see across all 3 subjects, 5 blue items were said yes to, 4 green items, and 2 new items. Now that's good, but oftentimes we want to know for individual subjects how many blue, green, or new items were they responding to. So one thing we're going to have to deal with here that we didn't have to deal with before is how do we get the pivot table to separate the data out by each subject? Because ultimately what we want is subject 1 to be in the first row, subject 2 to be in the second row, subject 3 to be in the third row. Well, the way we do this is with the participant variable. If we look at our data sheet over here, the participant variable scores the different subjects, subject 1, 2, and 3. So we can use this and we can drop it into the rows area. And now our pivot table is nicely sorting out the data from our different subjects. So we can see, again, this is what subject 1 did. If we think back to the first data file we looked at, subject 1 responded yes to 2 blue items and nothing else. Look at subject 2. He responded yes to 1 blue item and 2 green items and nothing else. Subject 3 responded yes to 2 of everything. Again, it might look like subject 3 was responding in the same way to all 3 categories, but we know that there were 3 green items, 3 blue items, but there were 6 new items. So this is actually, there were fewer responses to new items proportionally than there were to either of these 2 other categories. And another way to think of that is you can imagine blue and green are old items and none are new items, so there are actually 4 yeses to old items in total and 2 yeses to new items in total. So again, this is why you often want to switch away from your sum and go to something like your average so that you can see how often were people responding to these items on average. So returning now to our original question, what is the probability that someone would say yes to a blue item, yes to a green item, or yes to a new item? We can see our answer. There's a 55% chance that someone on average would say yes to a blue item, a 44% chance on average that someone would say yes to a green item, and about an 11% chance that someone would say yes to a new item. And so, on average, people are more likely to say yes to the blue than the green items. If this was a large number of subjects, so we knew things were reliable, we could probably say that blue items, whatever people were doing with blue items, was making those blue items more memorable than green items because they were more likely to recognize them, more likely to identify them during the recognition test. And new items, people were unlikely generally to respond yes to. By the way, one last thing, guys, when you do save your merged data file, make sure you go to File, Save As, and save it as an Excel file. Do not save it as a CSV file. I actually forgot to do that, and so you'll notice that when I reopened my data file, when I forgot to change it, now all my raw data is gone. My pivot table is still here, but it's no longer in pivot table form, so I can't edit it. So if you don't save your file as an Excel file, you're going to lose all your capacity to actually analyze your data. So I actually have just gone back and recreated my merged data file. And so now I'm going to go to File, Save As, and I'm going to change the file type to an Excel workbook. Click Save. Now when I reopen this file, everything will be exactly as I've got it here. So the important tip, don't forget to change the file type or you're going to lose a lot of your work. So that wraps up our video today. In the next video, we're going to carry on these analyses and we'll look at figures and a few other more advanced Excel things. All right, until then.